Hi, I'm Lara, and today we're going to go over graphing linear lines, or lines with a constant slope, or a scenario with a constant rate. So we're going to start today with a scenario that says Rebecca reads 5 pages each day. Find her rate and graph her progress, and then we're going to determine how many pages she has read after 8 days, and then after that, so maybe around 20 days, we can go even farther, but we're going to learn how to do that today. So the first part of this question tells us that she reads 5 pages each day, and it wants us to find her rate. Now, it essentially tells us that rate in the question. Every day, Rebecca gets up and she reads 5 pages. So her rate is 5 pages per day. Now, it's usually handy to write this out in a chart so we can find the amount of pages she's read after a certain amount of days. So let's do that. So let's start with, for example, day 0. Well, on day 0, she hasn't started yet, so she's read 0 pages. Continuing off after that, after 1 day, she's going to read 5 pages. After 1 day, she has read a total of 5. We're going to go to day 2, day 3, day 4, 5, and day 6. So if on day 0 she's read 0 pages, on day 1 she has read 5, she's going to read 5 more on day 2. So we're going to add 5 to the next day. So 5 plus 5 is 10. So after day 2, she will have read 5 more pages, or 10 in total. And same thing with day 3. We go from 0 pages, 5 pages on day 1, 10 pages on day 2. On day 3, she's going to read another 5 more pages. 10 plus 5 is 15. So as you can see, as we are increasing by 1 on the bottom here, plus 1, we are increasing by 5 pages. So after every day, we increase by 5 pages. We're going to keep going, plus 5 every day. So now we're just essentially counting by 5. So we've got 5, 10, 15. After 4 pages, that's 20. After 5 days, that's 25 pages. And after 6 days, that is 30 pages. So that is a good way to figure out some points. Now, we are going to figure out how to turn this into a graph, to graph her progress. Now, looking at this graph, I've split it up into an x-axis and a y-axis. And let's remember, our points on a graph are going to be x, comma, y. So we have to figure out which units, pages or days, belongs on the x-axis or the y-axis. So typically, time is going to go on the x-axis, because time just happens by itself. You don't really affect that. However, Rebecca does determine how many pages she's going to read on a given day. So it makes sense to assign x to the number of days, y to the number of pages. So as each day increases on the x-axis, y-axis is going to increase by 5. And we can treat this as points on the graph, right? X comma y. So to start, we are going to have 0, 0. On day 0, Rebecca's going to read 0 pages. And that is our point right there. 0, comma 0. Remembering our x-axis is our days, and our y-axis is our pages. Continuing from there, as we go up 1 day, we're going to go up 5 pages. Spaced accordingly on our y-axis, we go up by 5 so that we don't run out of room. On day 2, we read 10 pages. Day 3, we read 15. We're looking at the chart here. We're here right now. And then day 4, we have 20 pages. Day 5 is 25. And day 6 is 30. So now we have some points on our graph. We start with 0, 0, we end with 6, comma, 30. On day 6, Rebecca has read 30 pages. And we can connect that so it looks like a graph. It should line up, but we're freehanding, so it's a little tricky. Let's fix that a little. And it's a line, so it's going to extend in both directions with little arrows. However, we can't read negative pages, right? If we continue down back this way, you'd be in your negative days, negative pages. Now, unfortunately, you can't have negative days. So we are going to stop at 0, 0 there. So this line has what we call a slope. A slope is the angle of that line. So in this case, we say we have a positive slope. The line is going up this way. It's going in the positive direction. A line can also have a negative slope. So let's say we had a scenario that as days increased, the number of pages decreased. Then the line would go down this way. So as day 1 happened, we would go down. That's called a negative slope. Now that doesn't make sense in this scenario. You can't take away pages you've read. But the scenario tells us whether that slope is going to be positive or negative. In this case, we have a positive slope. Now you may be thinking, what exactly is a slope? What does it mean? Well, the slope is actually the rate, the unit rate of the scenario. So 5 pages each day. So as we look here, as we go up one day, we go up 5. Up one more day, up 5. And it's kind of like a staircase. So as we go 1 here, we go 5 up, 1 here, 5 up, 1 here, 5 up. That is our rate. Now we can also write our slope as rise over the run. Rise over the run is the vertical over the horizontal, right? We call the rise going up this way, the run going sideways. In this case, the rise is our y, is 5. So our slope is going to be up 5 over 1. Rise up 5, you go over 1. Right, we go up here, 5 over 1 once. And so our slope is 5. And we also call slope the letter m. So in this scenario, m, our slope, is equal to 5. And what did we say our rate was earlier? 5. So our slope is essentially our rate. Another way you can determine this is figuring out the change between 2 points. So in this case, we want to find out the difference between these two, the difference between these two. Now we've already determined this, right? We know that we go up 5 on the top for pages and we go up 1 on the bottom for days. But let's say we didn't know that for right now. Here we can get rid of all this. Well, what we could do is we could subtract. We could find the difference, right? So we could do 30 minus 25, the rise over the run, our x, which is 6 minus 5. And of course, we would get the same thing as down here. 30 minus 25 is 5. 6 minus 5 is 1. 5 over 1 is the fraction. 5 over 1 is 5. Or 5 divided by 1 is 5. That's another way to find the slope. It's essentially just finding the rate of the scenario. And that is 1 on the bottom. Now this translates another way to a more general equation. Looking at what we just did, you can also say that the slope, m, is equal to y2, the bigger y, minus y1, right? That's what we did here. We did 30 minus 25 over x2 minus x1. And that is called our slope equation. And we'll come back to that later and when we do another example. Another thing to note is the y-intercept. And the y-intercept is the point at which the graph, the line, hits the y-axis here, the vertical axis. In this case, it hits it right at 0. Let's say we had a graph that went like this, same slope, but it started up here. What this means is that on day 0, Rebecca has already read 15 pages. Oops, 15 pages. And then we're still going to go up by 5, so that'd be 20, 25, etc. In this case, the y-intercept tells us our starting point essentially is at 15, or the point 0 for an x, 15. And we usually call the y points of the y-intercept b. So in this case, b is equal to 15, and b is equal to 0 in our original scenario. So now we have a bunch of letters. And the reason I'm giving those to you is because we can write those all together in an equation that tells us to form the exact slope of this line and can help us find other pages, other days and pages that we can't quite fit on the graph. And that is called slope-intercept form. And it is written y is equal to mx plus b, where x and y are our points. So x number of days gives a y amount of pages. M is our slope, which you can find by subtracting. And b is our y-intercept. So for our original scenario, we found that our slope m is equal to 5. That's our rate. As each one day happens, we read 5 more pages. And our b, our y-intercept, is just at 0. So sticking those in, we keep x and y there because we use those to sub in later. Y is equal to 5 times x plus 0. And of course, plus 0 doesn't really add anything. So our equation is y is equal to 5x. That is the equation of this line. Now, if you put that in the calculator, this is the graph you're going to get if you put that in your graphing calculator. So how do we use this equation now? We'll clear this up a little first. Basically, what this equation tells you is that the number of pages is affected by 5 times the number of days that you read. So we can sub in points, substitute in our points from our graph to make sure this works. So for example, let's choose 10 and 2. And we're just going to specifically look at the x. So we're going to test this by saying, okay, our x is 2 days. 5 times 2 is going to get us 10. And our y is in fact 10. 10 is equal to 10, that's correct. So we know this equation is going to work. And same thing for other things. You can do 5 times 6 is 30, 5 times 7 is 25. It gets our right answer. Right? So now I asked for how much has she read after 8 days? Now that is farther on our table, we don't know, and it's farther up our graph. Now you could, of course, continue your graph, right, over 1 up 5 over 1 up 5, and land on the point 8, 40. That works, continuing your slope. So 40. Or you can put in an 8 for x. So y number of pages is equal to 5 times 8 days. That is 40. So after 8 days, Rebecca's going to have 40 pages read total. And you can extend even farther to bigger numbers. So it also asks us to find after 20 days. Of course, that would take forever on the graph. We don't have enough room for that. So we're just going to put in a 20 in for x, our number of days. 5 times 20, which is 100. So y is equal to 100. We know after 20 days, Rebecca will have read 100 pages. So that is how it all intertwines. And I hope that makes sense. So just to recap a little bit, in our scenario, we usually have a constant rate. And just to reiterate, constant means it's increasing the same amount every time. So in our scenario, every day, we increased 5 pages each time. That rate is equal to the slope of our line on a graph. And our slope is equal to the y-axis over the x-axis, the amount we increase each time or decrease if it's negative, which is the rise over the run. And we also call slope m. And we also have the y-intercept, which is going to be a point 0, comma, some number y. And we call that yb, that y value b in our equation. Taking it all together, y, our point y, is going to be equal to x times the slope plus whatever that number that y-intercept is. And that is called our slope-intercept equation. Hope that all makes sense, and that you learned something new today. Thank you so much for joining me.